All right, folks, now what we're going to be talking about are tissues. And I do suggest that you start looking at these early and often, because what we have found out over the years is the tissues is what it leads to some confusion with people, with students. Unfortunately, obviously, under the circumstances, we're not going to have any microscopic views of the tissues. So what we are going to do is we're going to go all through APR with these. So what we're going to do is we're going to get right into this, and we're going to talk about epithelial tissues, connective tissues, and nervous tissue. So what we're going to do is we're going to show you, if you haven't been onto your blackboard much, or if you haven't gotten into your connect section. When you get into the connect section, all we're going to do is you're just going to scroll down, and what you're going to do is you're going to come to this one right here. This is Anatomy and Physiology Revealed. That is the APR that I've been talking about. So all you're going to do is you're going to click on that link right there. And so when you come down here, when you look at this, it says select module up here. So when we click on that, you got all the different organ systems and body orientation. I know we haven't talked about chemistry yet, but we will. And we're going to click on this module right here. This is the tissues. And so what we can, when you come right here, and then what we're going to do is we're going to go from the microscope. You want to go with the microscope icon right here. Okay, and then you select topic, and then you can see all of the different tissues that come up. Okay, now all we're going to focus on for right now is the tissues that are in your checklist. There are more listed right now on here, but you do not need to know those. The big thing, folks, is we are going to stick to structures in the checklist only. If it's not in the checklist, you're not responsible for knowing it at this time. Okay? All right, so let's go ahead and take a break. Okay, so what we're going to talk about right now are the epithelial tissues. And I believe that you have 6 of them to know only, and those are the only 6 that you are going to have to know for your test. And these will also be the only 6 that you'll need to know for lecture as well. We're not ever going to do a situation where we have you learn one thing for lab and then we give you a bunch of other ones for a lecture. So we're going to keep that nice and simple. So again, just a real quick few notes on epithelial tissues for you to write down in your notes as we're going here. First one, what you need to know when we talk about epithelial tissues, cells are very tightly packed together. Okay, so cells are tightly packed together. Second part, what we want you to know is that that decreases the amount of blood vessels that can travel to the tissue. So epithelial tissue is what we call an avascular tissue. It really lacks a substantial blood supply. So if epithelial tissue is damaged ever, there's a very slim chance that it can recover. And then thirdly is epithelial tissue is a lining and covering tissue. So when we were talking last time about the visceral pleura, the parietal pleura, those membranes are made up of epithelial tissue. Also, too, we have a certain way that we name our epithelial tissues. And when you're looking in your checklist, you'll see a lot of the epithelial tissues start with either the term simple or stratified. Simple, when we talk about an epithelial tissue being simple, we refer to a simple being one layer of cells. Stratified tissue or epithelial tissue means multiple layers of cells. Be 2, it could be as many as 40, if not more. So again, simple epithelial tissue is a single layer of cells. Stratified are multiple layers of cells. And then also you'll see the term squamous, cuboidal, or columnar in your notes. That's referring to the cell shape. So a squamous cell is flat. If you want to see what a squamous cell is, grab a grape, step on it, and you have a nice flat cell. That's what a squamous cell is. A cuboidal cell, the name says it all. It's a cubed or a square. And then a columnar cell is quite simply a rectangle or a column. And then to complete the way we name our epithelial tissues is you always add the term epithelium after that. So if we were looking and we would see a single layer of flat-shaped cells, the correct way to name that tissue would be simple squamous epithelium. So we want you to fill it all the way out. And so what we're going to do is, and then also too, if you notice in your checklist, there are some terms in bold underneath epithelial tissues: basement membrane, cilia, goblet cells, lumen, cell nucleus. Those should be visible on most of the epithelial tissues, but sometimes they don't come clear depending on the picture that we use. Make the note, a basement membrane is what separates epithelial tissue from underlying connective tissue. Again, sometimes the basement membrane don't come out clearly, but sometimes it does. But again, it separates epithelial tissue from underlying connective tissue. A lumen is a free or empty space. So again, depending on what view you're looking at the tissue, that lumen could be above or below the epithelial tissue in question. A very good way to understand this, and don't worry about orientation of a picture, but if you find an empty space or the lumen, and then you find a basement membrane, everything between the lumen and the basement membrane, that is the epithelial tissue in question. That is always a good way to understand that. And then also too, cilia and goblet cells are associated with epithelial tissue, but not all epithelial tissue has those. And we will explain which ones do as we move on. And then a nucleus. For the most part, all the cells should have a nucleus. But sometimes when you're looking at these tissues, you will not see a nucleus in every cell, because sometimes the nucleus is deeper into the cell or is in the section that they cut off. So if you don't see a nucleus all the way through all the cells, don't panic, it's okay. Okay, so we're gonna go ahead and we're gonna get right into our epithelial tissues. All right, folks, so we're back, and again, where we're gonna go down the epithelial tissue. And so what we're gonna first look at is simple squamous epithelium. And again, what we are looking at, we're looking for a single layer, of flat-shaped cells. And I can see that right here. So there are my cells right here. They are very flat. Now, if we look, we can see this dark stained purple structure right here. That is the nucleus right there. There's the nucleus right there. There's the nucleus. But if we look at this cell, there is no nucleus. Again, don't let that bother you, because again, that could be deeper into the cell, or again, the part that cut off. Now, the basement membrane does not show up that well on here. But this right here, this is all connective tissue right in through here. And if we look right here, this clear area right above the simple squamous epithelium, that is the lumen right there. Now, if we come back here and I click on it, and again, this is the nice thing about APR. If you just come over here and click on simple squamous epithelium, it's going to highlight blue. So there it is right there. There is our simple squamous epithelium. And again, if we want to come down here, you just click on the squamous cell. It shows you one squamous cell highlighted, and you can see how flat it is. And just for good measure, if we want to show you the nucleus of a squamous cell, here it is right here. You can see that it's highlighted in blue. Now, also what we can see on this tissue right here, we can see simple cuboidal epithelium. Here, we can see a single row of cube-shaped cells. Okay, and we can see the nucleus right here very nicely. We can see a lumen out here, and we can see a faint purple line running right here at the base of these cells right here. That right there is the basement membrane. And again, because again, the basement membrane separates epithelial tissue from underlying connective tissue. And again, just to show it to you, we're going to click on it and you'll see that area become blue. And so there is my layer of simple cuboidal epithelium. But if we come back to so again, what's the appearance? The appearance of simple squamous epithelium is a single layer of flat-shaped cells. We will ask for location on some of these tissues. And so we're not going to get crazy with location, but what I want you to write down for right now, where do we find simple squamous epithelium? The locations are the lungs. Number 2, the kidneys. Number 3, blood vessels. Okay? So again, if we come down, what's the appearance for simple cuboidal epithelium? Simple cuboidal epithelium, the appearance is a single row of cube-shaped cells. Now what we're going to do is we're going to come back, we're going to go to another picture. And again, we do not expect you to be master histologists by the time this is all said and done. But what we do want to look at is this picture right here. Now, Mr. Fogel and I have been teaching this for quite a while. And what ends up happening is when we say, name this tissue, and people automatically want to say, oh, that's stratified cuboidal epithelium. Because why? Well, I can see the multiple layers of cube-shaped cells. Well, actually what that is, this is still simple cuboidal epithelium. And yes, I know it looks a little bit different, and that's why we want to show this to you. We don't want you guys to learn all this on your own. That's not fair. That's not what we call teaching. But if I come right here and I look, what do I have right here in the group of this cells right here? I have a free space. That's my lumen. If I look, well, this one will be even big better. There's my lumen right there. Now, everybody should be able to see that nice dark purple line right there. There's a basement membrane. So again, what's the definition? Where do we find our epithelial tissue? Between the lumen and the basement membrane. And if we look, how many layers of cells do we have right here? We have a single layer of cube-shaped cells. And again, can we see a nucleus? Yes, we can see the nucleus very nicely on these cells, very nicely. But again, so that is simple cuboidal epithelium. Now again, here's another layer of simple cuboidal epithelium. Basement membrane, lumen, what's in between? A single layer of cube-shaped cells. So again, that picture could be fair game, but again, if you check your checklist, you don't even see the term stratified cuboidal epithelium in there, so you're not responsible for it. Okay, so the next, and location for simple cuboidal epithelium, we're going to say the thyroid gland, we're going to say the ovaries, and then also to the kidneys. Now, some of you are probably saying, wait a minute, he just said that simple squamous epithelium is found in the kidneys as well. So what you need to remember, folks, when we talk about organs, an organ is a structure that is composed of 2 or more types of tissue. So we can have multiple types of epithelial tissue in a particular organ. Okay, so those are the 3 that you need to know for that one. Now what we're going to do is we're going to move on to simple columnar epithelium. And what I want you to stop and think about before I even tell you, say what you would think the appearance of simple columnar epithelium would be. Just say it to yourself right now. And plus, there's no wrong answer today because this isn't a test. And Mr. Fogel and I won't be able to hear you anyway. So shout it out loud at home. Be proud. So we come right here. Let's come on down to simple columnar epithelium. Let's get out of this one real quick and let's come to this one real quick here. Where are we? Right here. So what we have here, again, if we look at the cell right here, we can make out the rectangular shape or the column-shaped cell. We can see a nice lumen right here. Okay, we can see We can see a basement membrane faintly, but the basement membrane is there. So if we find a basement membrane, find the lumen, what is found in between the lumen and basement membrane, and I know you're probably going to be sick of me saying that, but that is the epithelial tissue in question, folks. And so this would be simple columnar epithelium. Now, where's the location of this? For right now, all we want you to know is the digestive tract. The digestive tract for simple columnar epithelium. We're going to show you another type of simple columnar epithelium right here. And what we want to show you this for is we want you to see these white cells right here. These white cells are called goblet cells. And what goblet cells do are they produce mucus. Now, here's the note that I want you to put in your checklist. Goblet cells are only associated with columnar epithelium. Goblet cells are only associated with columnar epithelium. And again, we may not see goblet cells in every type of columnar epithelium, but if we do have a goblet cell, columnar epithelium is what it's going to be part of. And again, what do they do? What do goblet cells do? They produce mucus. Okay, the next one. This is a mouthful right here, folks. Pseudostratified ciliated columnar epithelium. That's just fun to say it. So say that all day long around your house. Pseudostratified ciliated columnar epithelium. Now, the thing is we have to look at, we're going to look at this right now, and what ends up happening is, let's see. One down. Oh, right here. So when we see this, one of the big keys on what you're looking for, if you say the name out, pseudostratified ciliated columnar epithelium, that tells us exactly what it has. See all these little tiny hair-like structures? Those are cilia. Okay? And then also, what do we have? We have these white cells again. Those are, again, goblet cells. Okay, now when you first look at this tissue, again, what it looks like is we have multiple layers of cells. But in all actuality, folks, what we have here is one layer of cells. And that's where the term pseudo comes from. Pseudo means false. So it gives the false impression of being stratified. But what happens are the cells grow at different rates, and some of the cells never reach the lumen. They get cut off by the two other cells growing on the side of them. So here's the note. All of the cells make contact with the basement membrane in pseudostratified ciliated columnar epithelium, but they all don't reach the lumen. Now again, in the summer, we don't have much time in the summer. I know this class moves relatively quickly, but again, the key thing, what you're looking for on this tissue, folks, are the cilia. They stand out very greatly. Okay? So that, and again, location for this tissue, quite simply put, the respiratory tract. The respiratory tract. Okay, the next one, folks, here we go. Stratified squamous epithelium. Holy cow, look at that mess. Conundrum. So if we look, we can see our lumen. The basement membrane would be running right here. Okay? Now what we can do is we can look at all the number of cell layers as we move up through the tissue. So that is definitely stratified. Now we got to come out, where do we get the term squamous for this tissue? Because I'm looking down here, I don't see many flat cells at all, folks. I see hardly any flat cells. But when we name our stratified tissues, we give the cell shape name based on the outermost layer of cells. So if you start moving up through the layers of cells here in this tissue, you'll notice that the cells are starting to flatten out as we move up through the layers. So by the time we reach the outermost layer, we can see the cells are relatively flat. And this is where the name squamous will come from. It's based on the outermost layer of cells in stratified tissue. So again, that is where we get this is where we get the term squamous. Stratified's taken care of. We can see the multiple layers of cells right there. The cell shape name is taken care of because we go based on the outermost layer of cells. So that's simple squamous epithelium. Locations, folks. Location for this tissue is the epidermis of the skin, which Mr. Fogel talked to you about in the integumentary system. So that is the epidermis. And the epidermis of the skin is made up of stratified squamous epithelium. Also, the mouth contains stratified squamous epithelium. And one more location for good measure, vagina contains stratified squamous epithelium. And our last one is, the last epithelial tissue is transitional epithelium. And you can see the term stratified in parentheses. And yes, you can call it stratified transitional epithelium, but if you leave stratified off, we are fine with it. Transitional epithelium is fine by itself. Now, this tissue right here, here we go, transitional epithelium. It looks a little bit different than everything else so far. Now, the thing about transitional epithelium, which sets it apart from all the other epithelial tissues, is it has the ability to stretch or expand and then return back to its normal shape. That's the one thing. All the other epithelial tissues, if they've stretched too far, they're going to tear. Transitional epithelium, though, has the ability to expand and then return back to its normal shape. The only epithelial tissue that's capable of doing that. And we're going to show you what it looks like real quick up close. And if you look, you can see the multiple layers of cells. No problem about this. Now, the nice thing about this, what you were doing when you try to identify this, the best way to do is look at the tops of the cell. The tops of the cells are rounded. Okay, and if you look at it, they look like a bunch of little toes or little fingers all stuck together. But you can see the roundness of the tops of the cells. That is a dead giveaway for transitional epithelium. Now, the location for this tissue is the urinary bladder, the ureters, and the urethra. So it's found within structures of the urinary system. And again, think about it when you drink that 52-ounce soda during the course of the day. Does your bladder expand at some point? The answer is absolutely yes, it does. But then the bladder will just shrink back down the side. It will back to its original size. Why? Due to the transitional epithelium that lines it.